Hello and welcome to the new style Edexcel GCSEs. These are the ones that go from grades 9 through to grade 1. This is paper 1MA1/2H. It's the second paper in the higher tier. It is a calculator paper, so we are allowed to use calculators, and we're picking up in question 14. Prove algebraically that 2n plus 1 squared minus 2n plus 1 is an even number for all positive integer values for n. Okay, under exam conditions you won't have time to really think about the beauty of this statement, but it would be nice if we could just take a second here just to appreciate what this question is asking. It's basically saying if you've got any odd number, because 2n plus 1 will always be odd, if you take any odd number and you square it and then you take away the same odd number, you are always going to have an even number. I think that's quite amazing. I think we should just take a second to appreciate that. Okay, so what we're asked to do is to prove this algebraically, that this statement is true, that you can square any odd number, subtract the same odd number and get an even number. So for all positive integer values for n, this will always be odd, this will always be odd. Okay, so let's expand out these brackets here. So we've got 2n plus 1 squared, so 2n plus 1 squared is equal to, I think the easiest way is to just write it out in full. We can use the binomial expansion, but it might be easier just to write it out in full. Unless you're really confident to do this in your head, let's write it out in full. And that's equal to 2n times 2n is 4n squared. 2n times 1 is plus 2n. 1 times 2n is plus 2n. And then 1 times 1 is 1. So basically what we're doing is making sure that everything in this brackets is multiplied by everything in this brackets. Okay, so we can simplify that to 4n squared plus 4n plus 1. So this then, when subtracted from 2n plus 1, so 4n squared plus 4n plus 1 minus 2n, and now we're subtracting all of this 2n plus 1 from this, so we're subtracting 2n and then we're also subtracting this 1, so this becomes minus 1, and that's equal to, well, these ones cancel out and this 4n minus 2n becomes 2n, so we're left with 4n squared plus 2n. Now I would be tempted to pull out the 2n, but because we're trying to prove that this value will always be an even number, I'm only going to pull out the 2. So this is equal to 2 into 2n squared plus n. And I'm not worried about this bit here, except to say that if n is a positive integer, then this will be a positive integer. So I'm going to write if n is a positive integer, then 2n squared plus n will be a positive integer. And then I'm going to say any positive integer when multiplied by 2 must by definition be even. That's because the definition of an even number is a number that if you divide it by 2 you will get a positive integer, and if this is a positive integer then if we divide it by 2, the 2's cancel out and we're left with this, which is a positive integer. So this must be an even number. Okay, I hope that was helpful, and I'll see you in the next video.